Welcome back to our discussion of the unit circle. And in this video, it's a little bit of a shorter video, but we're going to talk a little bit about how we can use the unit circle to see the properties, the even and odd properties of some of your trig functions. So I'd like you to look at this picture right here of a circle. It's a unit circle, right? And I have given you an angle T in that first quadrant with an identical measure in the fourth quadrant, which we'll call negative T. And so their coordinate as we look at where the radius hits the circle itself is xy in the first quadrant and x negative y in the second quadrant. Well, this allows us to kind of talk a little bit about what is going on with the cosine functions of the positive and negative versions of these angles and the sine functions as well. So if we look at cosine of t, we can tell that since this is on the unit circle, we're just interested in the x value. Right? And if we're looking at cosine of negative t, again, we're just looking at the x value. So when f of x is equal to f of negative x, we call that type of function an even function. So let's think about sine for a second. Let's look at that angle in the first quadrant first, and then the sine of t is going to be just y. And if I want the negative sine of t, I'm just going to put a negative in front of that y. And then if I'm looking at the sine of negative t, that's going to be this y value, which is negative y. Okay, and so you may know this relationship as well. When f of negative x is equal to negative f of x, we call that type of function an odd function. And so if we're looking at these functions, we can definitely say that the trig functions have either even or odd characteristics. Cosine and its reciprocal secant are the only ones that are even, and then the rest of the trig functions are odd functions. So that's a handy little thing for us to know, and then we can actually use it to help us evaluate the trig functions of negative angles. So if we know that cosine is an even function, we know that cosine of negative x will be the same as cosine of x. So we can say that the cosine of negative 60 degrees is the same as the cosine of 60 degrees, which we know to be 1/2. Now, if we look at this next example, sine of negative pi over 4, well, the sine of negative pi over 4, sine is an odd function, so the sine of negative pi over 4 will be the same as negative sine of pi over 4. And if I know what sine of pi over 4 is, which is rad 2 over 2, I just put a negative out on front of it, so both of these expressions are equal to negative rad 2 over 2. All right, so here we are at tangent of negative 120 degrees. So tangent is odd. So that means the tangent of negative 120 degrees will be equivalent to negative tangent of 120 degrees. Then all we have to do is evaluate tangent of 120 degrees, which is negative rad 3. And then we need to make that negative rad 3 negative, and so we end up with positive rad 3. And then if we're looking at cosecant of negative 5 pi over 6, Cosecant is also an odd function. So we know that the relationship is, so we know that the cosecant of negative 5 pi over 6 is equal to the negative cosecant of 5 pi over 6. And since cosecant is the reciprocal of sine, I'm looking for the reciprocal of sine of 5 pi over 6. Sine of 5 pi over 6 is 1/2. The reciprocal of that will be 2, and then I need to negate that. And so my answer would be -2. All right, I told you this was a pretty quick one. The next video we will talk about periodic properties of the trig functions. See you then.